Yeah, you're all right. Yeah, you're fine. Okay, why isn't this working? Oh, all right, there we go. Okay, we're going to get started. Today is Wednesday, April 14th. We're going to go over lesson 3.4, polynomial functions and graphs. What's due Sunday, the 18th? 3.2, and this homework here, 3.4. There is a quiz that's online. This one's required quiz for chapter 3. Make sure you do that for Sunday for a quiz grade. Also, I sent out an email for some extra credit if you do the survey. I've gotten a few responses back. I don't think I've gotten anything from this class yet. But what? What's the survey? I sent an email out for a survey as far as the program and math. Have it due by this Sunday. Yeah. Yeah, good question. Thank you for asking that. Okay. We're going to go over lesson 3.4. So let's get started with that. Here it is. Okay, so you have PowerPoint notes. I think they've been helping you out pretty well. Lesson 3.4, polynomial functions, graphs. And mostly we're going to look at graphs, not so much into the applications of the models. We're going to look at end behaviors. We're going to look at graphs of, this would be the leading term, or the power function. Ax to the n power, graphs of general polynomial functions. Okay, nothing to copy here. This is basically identifying end behavior for even polynomials. Polynomials that behave like x squared, x to the fourth, x to the sixth. This shows how the graphs differ between, they're similar, but there's differences too, in that x squared is the one that's in green, that's the widest one. It widens out at the top, but narrows at the bottom. X to the fourth, that's the blue one, that widens out further on the bottom, narrow as you're going towards the top. So there's similarities, but there's also differences. Mainly the near the vertex tends to widen out as the exponent gets larger. Okay, here, this is identifying end behavior for odd functions like x cubed, x to the fifth, x to the seventh. X cubed is the green one that, so as the exponent gets larger, again, it tends to widen out at the x-axis. So that's just to compare and contrast between x cubed and other odd powered functions. All right, nothing else to really copy there. Okay, now here's where you've got some answers to put in. This one here to the left is an even degree and it's positive. So it's going to open up to the left and up to the right. So the end behavior, what we're looking for here is what does the end behavior do? In other words, it's going to do different things in between these. It may go down and then up and then back down again. But at the end, it's going to go up and to the left and up and to the right when x squared is positive. So this is an even function, and its coefficient, the leading term, is positive. So here, down here, you have a negative x squared. It reflects about the x-axis or flips, right? Now the end behavior is down to the left and down to the right. For odd degree, those are even degree polynomial functions. Odd degree is where the leading term is like x cubed, x to the fifth, x to the seventh, and so on. And here we have a positive x cubed that goes up and to the right and ends up down and to the left. The negative here is going to make it reflect about the x-axis. Now, instead of being up and to the right, now it's down and to the right and up and to the left. So it made that graph flip. Okay, any questions there? Okay, so another look at an odd degree polynomial. Here we have this polynomial is 2x cubed plus 8x squared plus 2x minus 12. You can see, you look at the leading term, what starts off, the 2x cubed, you can see that it's positive right here, and it's cubed, so it's odd. So it's going to end up and to the right, like this, and down and to the left. So you can see that end behavior, and it's going to do different things in between. The next one, the middle one, is a negative x cubed. So that's where it flips, right? Instead of being up and to the right, now it's down and to the right and up and to the left. And so you see that end behavior because of the leading term. You look at the leading term. And the last one is x to its leading term is x to the fifth. So it's positive and it's odd. So that's going to end up and to the right and down and to the left. And you can see it moves different ways up and down. But eventually it's going to go up and to the right and down and to the left. So those are some examples of some odd degree polynomials. Okay. So the main thing that we're looking at is the end behavior for right now. Okay, even degree polynomial functions, here's an x to the fourth. So it's positive and it's even, right? 2, 4, 6 are even numbers, right? So the exponent is even, and it's positive, so it's going to go up and to the right, and it's up and to the left for its end behaviors. And it's going to go up and down, but eventually it's going to go up and to the right and up and to the left for the end behaviors. Here, you have a negative x to the sixth. So it's negative, it's going to make that graph flip, right? And about the x-axis, or reflect about the x-axis. And since it's even, instead of being up and to the right, it's going to be down and to the right for an end behavior, and down and to the left for that end behavior. And it's going to go up and down and up and down. But eventually, the end behavior is the same for all negative even powers. Any questions with that? Okay, so let's take a look at some problems. And so for the following exercise, determine the end behavior. So this is similar to some of the homework problems you're going to see. So let me get a marker here. So we're going to start off with, here we go. Okay, determine the end behavior. Okay, we've got f of x equals to x to the 4th. Okay, so what you're going to do is you're going to draw a graph, and you've got lines to the right. So because this is positive and it's even, it's going to be up, right, up, left, up, right, up, left. So that's our end behavior. That's all we got right there. Okay? Questions with that? All right. Can we go ahead and get off the cell phones, please? Appreciate it. Okay, let's try another one. F of x equals to x cubed. So what is this? It's positive, right? And so is this an even or an odd function? Even would be like 2, 4, 6, 8, right? Odd would be like,
So it would be 1 up, 1 down.
yeah. So it's odd. So it'd be up, right, down, left. So the end behavior is up, right, down, left. So you're going to see like diagrams like this on the homework. All right. Okay, the next one. Looks like f of x equals to negative x to the 8. So that negative, that's going to make it do what? Yeah, it's going to make it flip, right? So it reflects. And this is even, so what's the end behavior going to be? It's even, right? 8 is an even number. So is it going to be up to the right or down to the right? Down, right, good. And how about on the left side? Down, left, good. So it's down, left, down, right. Okay, questions there? Okay, let's try this. F of x is equal to a negative 2x to the 4th minus 3x squared plus x minus 1. Okay, so all we look at here is that leading term. That's all we look at. And that's going to tell us what our end behavior is. So it's even and it's negative. So our end behavior is going to be what?
Down, right, down, left.
Yeah, down, right, down, left. Down.
So it's going to look like the first one?
Yeah, you look at the first one is the only one that's going to tell you what the end behavior is. Okay, down, right, down, left. All right.
So this is negative.
Yeah, it's reflecting, right? It reflects it. So if you have one like let's say, now this wasn't on the slide, but let's say we have f of x equals to a negative, instead of, no, let me make it positive. Instead of 3x squared, let's make that 3x cubed plus x minus 2. Okay, so It's x cubed, right? So therefore its end behavior is going to be what? Yeah. Up, right, down, left. Up, right, down, left. Okay. Any questions there? Okay, we'll do one more extra that's not on there. Let's say we have f of x equals to a negative x to the fifth.
That'll be up, left, down, right.
Yeah, up, left, down, right. That is correct. Up, left, down, right. Good. Questions?
So the question on the test for this or the homework would it just be this?
Yeah, because it builds later on. So this is like a piece to the puzzle on how you're going to graph polynomials later on. Okay. Next, let's go back to our slide. Okay, graphs of general polynomial functions as a quadratic function and absolute value of f of x equals a x to the n determines the width. When a is greater than 1, it stretches it vertically. So it makes it like longer. It's like it makes it longer and narrower. When a is between 0 and 1, in other words, a fraction, like 1/2 or 2/3, a fraction, then the graph shrunk, is compressed vertically and makes it wider. So you want to put wider in there. So it makes the graph wider. So let's see what that looks like on the board. Well, let's see what we get here. So yeah, let's do that. Okay, so in other words, if we have something like this, y equals to 3x squared. Well, x squared, y equals to x squared, this is, we'll call this the parent graph. If you look at the original graph before, without the 3 in it, it's going to be, when x is 1, y is 1. So, and when x is -1, y is +1. But with the 3, it vertically stretches by a factor of 3. So in other words, now, instead of being at 1, 1, like this point, it's going to stretch. So now the graph is at 1, 3. So it stretched that graph in relation to the distance from the x-axis to the curve. It stretches it. So if we had y equals to, let's say, 1/2 x squared, now, instead of being at when x is 1, y is 1, it's going to widen out. It makes the graph wider. So now, instead of being at 1, 1, now it's at 1, 1/2. So it widens that graph out, okay? Or it compresses it, the distance between the curve and the x-axis, all right? So that's what we're talking about there. We're not going to get a whole lot into vertical stretching or compression, but it's important that we go over it. Okay, so that's that slide. All right, now you got some things to fill in. Compare, now I split this slide into two slides. So the first half, you have the graph of the function is negative ax to the n is reflected across the x-axis. So you're going to put negative ax to the n in there, okay? And then the next line, f of x equals to ax to the n plus k. So you're going to write a to the x to the n plus k. It shifts up. So when you get a plus something, it shifts it up. Well, we already went over positive and negative graphs and even and odd, but we did not look at up or down. So let's look at an example of that real quick. So here's our board again, and we want to start with y equals to x squared, the parent graph. And so that has a vertex at 0. And so let's say we want to look at y equals to x squared plus 3. So this is going to shift this graph up. Shifts up 3 spaces. So now the whole graph shifts from 0, goes 1, 2, 3. Now this vertex is up here at 3. In the past, we did a whole table of values to graph a function where we had x and y, and we put in -2 and -1 and 0 and 1 and 2. Remember that? And then we plugged in these numbers. -2 squared is 4, -1 squared is 2, 0 squared is 0, 2, 4. And then we plotted those points. Well, that's fine to start with, but when we get into more complex graphs, we want to use what we call transformations. So in these transformations, when you have x squared plus 3, it shifts it up. So if we had y equals to x squared minus a number like 2, now that's going to shift down 2 spaces. So now we start with the parent graph with a vertex at 0, and it shifts down 2. So this vertex is 1, -2. And now that's what that graph looks like. Okay. So the transformations is a real good way to graph, different types of graph very quickly. Okay. Now, the next slide, you've got the graph of f of x, and you're going to put in here a parentheses x minus h is translated h units to the right when h is positive, and h units to the left when h is negative. So inside parentheses, it's going to shift it right or left, but it's going to be opposite of the sign. So let's see what that looks like. So for example, if we have here y equals to x minus 4 squared, this tells you, the square tells you that it's going to behave like an x squared, but this is going to shift right 4 spaces. So it's going to be opposite of the sign that's inside the parentheses. Different than when the sign is outside of the parentheses. So this over so I got room. So this shifts 4 spaces to the right. 1, 2, 3, 4. And then you just draw your parabola from there. So the parabola is always the same shape, but it just shifts. Shifts. Okay? You're just taking this graph and you're just shifting it up or down or right or left. Well, let's see what it looks like shift the other way. Y equals 2x plus, let's say, 1 squared. Now this is going to shift left because it's opposite inside. So that means the vertex, this vertex is going to be at -1. And everything else shifts with it. Okay? Questions there? All right. And then the last one is a combination. It's going to shift it right or left when you've got a to the x minus h to the n plus k. Now it's going to shift up, right or left, and up or down. So it's a combination. So you can have more than one transformation in a graph. Okay? Questions there? Okay. So let's look at some problems. So your next slide that you have, let's go back to the board. Your next slide that you have is f of x equals 2x to the 5th minus 2. So you look to see if it's even or odd. If it's even, it behaves like x squared. If it's odd, it behaves like x cubed. So this x to the 5th makes it behave like x cubed. It's positive, right? So the end behavior is going to be, we know it's going to be up and to the right and down and to the left. So that's a piece to the puzzle for us. Okay, the -2, that's going to make it shift. Careful now, it's outside the parentheses. It's different than if it was.
Also within parentheses.
So
it's the opposite, but outside.
Yeah, if it's outside, this would make it shift right too. But this is outside.
That would make it shift left.
Careful now, it's like, if it's outside, it's either going to shift up or down. So this will shift down too. If it was inside the parentheses, then it would shift right. But when there's no parentheses, like this, it shifts down. So it makes a difference if there's parentheses or no parentheses. Okay? So it shifts down. Well, here's x cubed, right? This is what x cubed looks like. So all we're going to do is we're going to take this middle here, we call it the point of inflection. It's where it opens up and then opens down. So this is going to go down. This whole graph is going to go down 2 spaces. So 1, 2, -2. And we said it opens to the up, to the right, and down to the left. So when you draw it, you start from the middle and draw it up like a positive parabola and then down like a negative parabola. So it's like 2 halves to a parabola. half up and half down. And that's your graph, okay? So we use the end behavior to start off to tell us which way it's going to end up. And then we use the transformation to tell us which way it's going to shift. All right, questions there. All right, let's look at another one. This is the next slide. We have f of x equals 2 parentheses x plus 1 to the 6th, okay? So it's even, right? This is even. So it's going to behave like what? X squared or x cubed?
X.
Yeah. It's going to behave like x squared because x squared is even and x to the 6th is even, right? So it behaves like x squared. So it's going x squared. That's the parent, what we call the parent graph, right? For x squared. So it's going to look like this. So that means the end behavior is going to be up, right, and up, left. Okay? So we know the end behavior. We look, this is parentheses, right? So that means inside parentheses it's going to make it shift either right or left. If it's plus, it's going to shift it to the left. Yeah, it's going to shift it to the left. So it shifts left 1 space. So our graph is going to look like, here's -1, and we said it behave like x squared. So it's going to come up like this, up to the right and up to the left. And that's all we got to do. Okay? Questions there. So the main focus is that point that starts off at the origin. Where did that end up? That is the most important point. Okay? Everything else follows that point. All right, any questions with that one? And because it's x to the 6th, it's actually going to be wide. It's going to have like a wide bottom to it. Wide bottom. It's going to be widened out. Okay. All right. We good? Can I erase this? All right. Let's look at the next slide. Here we have f of x is equal to x cubed plus 27. Well, this is pretty easy, right? It's going to behave like x cubed, right? Because it's got an x cubed in it. So it's going to behave like up to the right and down to the left. And so the transformation here is it's going to shift which way? Can we go ahead and get the cell phones, please? Appreciate it. Which way is this going to shift?
No, it's shift down. Wait, it's down.
If it's, okay, let's go back over these again. If this is f of x equal to x cubed plus 27, it shifts up 27. If it's f of x equal to x cubed minus 27, it's going to shift down 27. Okay? If it's f of x equal to parentheses x plus 27 cubed, like that, in parentheses, now it's going to shift left 27. And if it's f of x equal to x minus 27, parentheses cubed, then it shifts right 27. Okay? So we determined that this is going to shift up 27. So this point is going to go up. So this will go up to 27 like that. So that is going to, from this point, okay, it's going to look like this graph here, the parent graph for y equals x cubed. But this point is going to be up here at 27. So this will be, this point is that point of inflection we talked about, and that'll be up, right, down, left. Curve, so it's going to curve up to the right and curve down to the left. Okay? Yeah. Oh, what, this here?
Yeah.
Okay, sure. I'm recording this on video, so I'm going to post this on there so y'all can watch the whole thing later. Okay. Okay. Any other questions there? So I'll leave this here and we'll do another one. Okay, so the next one is f of x equals to x to the 6th minus 16. Okay, so the 6, is that going to, x to the 6, is that going to behave, is that going to be like x squared or x cubed? If it's even, right, it behaves like x, well, which one is even, x squared or x cubed? Yeah, x squared. So it's going to behave like x squared. So we start with the parent graph of x squared, because this is going to behave like x squared, because it's even, okay? And then the minus 16, what's that going to make it do? Shift which way? What's that going to do? Up, down, right, or left? 16. Down. Okay? It's going to shift down. It would shift right if it was inside parentheses like this. Okay? If it's inside parentheses, then it's going to shift to the right. But because it's not in parentheses, it shifts down. Okay, so we draw our graph, but it's good that you answer because that's how you learn, right? So now this will be down here at negative 16, and so we have our parent graph, so this graph is going to be down here. And there we go, okay? Questions? Okay. And then one more. We've got, for this slide, we've got f of x equals to x plus 3 to the 5th. Okay, so you asked yourself, is this even or odd? Well, 5 is what? Odd number or even number? Odd number, right? So is it going to behave like x squared or x cubed? X cubed, yeah, because cubed is 3 is odd, right? X cubed is odd. So it's going to behave like x cubed. Well, x cubed is up and to the right and down and to the left. So you have to get down the parent graph. Is it like x squared or x cubed? Did it flip or did it not flip? Okay, here's our shift. Which way? It's going to shift 3 spaces, but it's going to shift at 3 up, down, right, or left? Left, very good. Left. Left. 3 spaces. Okay, so that means our graph shifted 1, 2, 3 spaces. So it's going to look like this graph here, but this point of inflection, is now here at -3. So you start with that point and you go up to the right side, curve it down to the left. It's not linear, it's not like that. It's curved. Okay? Questions? All right, doing good. I'm going to leave this up here just in case we need to refer back to it. All right, next slide. F of x is equal to a -2. Parentheses, x minus 1, close parentheses, cube plus 3. So the first thing you always want to do is get the end behavior down. So we look at this, right? So is this going to behave, this is going to behave like, this one's pretty easy, right? It's going to behave like x cubed. But it's negative. So this is going to behave like a -x cubed because of the negative in front. So the sole purpose of this negative is to flip that or reflect it. So it's going to behave like a -x cubed. Get a little clearer. So instead of being up and to the right, it's going to be what? Down and to the right and up and to the left. So this is our parent graph that we start with. Before we do any shifting, we got to figure out how are we going to start. Okay? Now, inside parentheses, it's going to shift one space, but is it going to shift one space which way? To the right. Very good. Right. So we one space. And now outside the parentheses, the +3. So this is going to shift right one space. So right one space, so it's that. But now this +3 is going to make it do something else, right? Up. Good. Up 3. So it shifted right 3, and then right 1, and then up. So it shifted right 1 and up 1, 2, 3. So this, oops, no, it's the other way. This way. So now, right 1, up 3. Now, so it's up here. And it's going to go up to the left, down to the right, because it's negative. Yeah. So that's why it helps to start with the parent graph, the end behavior first, because it's easier to figure out the end behavior. And then once you get the end behavior, then the shifting part is easier. Okay? Questions with that? All right, so let's try another one. Just let me use it. Okay, we're doing good. Use this board here, because then I can refer back to the other one if I need to. All right, here we have f of x equals to 2. And then x plus 1 squared minus 6. So it's going to behave like an x squared. And is that positive or negative?
So which one?
Positive. Now the 2 is going to make it stretch by a factor of 2, but you're really not going to be able to tell by looking at the graph. So we don't even mention that. But that's what it's doing. That's what this 2 does. It stretches it. We get more in a stretching or compression when it's just by itself. All right, so it's going to behave like a positive, like x squared. So it starts off like this, right? There's our parent graph, because it's positive and it's x squared. So the x plus 1, that's going to make it shift to the left. Good. Left. 1 and the minus 6. Down. Good. Excellent. Down 6. So it helps to write out the transformations. First, do the parent graph, the end behavior, and then write it out what the transformation is, and it just makes it easier. So this will be left 1 and down 6. 1, 2, 3, 4, 5, 6. So it's going to be down here, and so we said it's going to behave like an x squared, but it's left 1 down 6, so it's going to behave like this. Okay? Questions there? All right, one more real quick. Or that's it. That's the one. That's it. That's the last one. Okay. Any questions? Good work. That's all for today. Have a good day.